Hi everyone. Today I'm going to show you in a real project how to use civil-based steel connection program to design connection in a real steel project. In this demonstration, I'm going to show you around 25 steel connection in a real steel connection project like this one. Pretty much this one. I'm going to. It's a pie rack. It's a steel pie rack. There will be a PDF file associated with this tutorial. You can download on the description part of this video. The YouTube video description part. There's a download link there. You can download this PDF file. So there are steel construction drawing with connection ID and elevation, plan view, and the steel connection. It comes from a real project. I will demo to you around 25 connection design here. So I would say, first, how to start this program. This web address link, you can start a program. It's called asp.civilbay.com/connect. That's the address. You can type in the address bar. This program use Google Chrome. So copy this address to your address bar and type in. You will start a program. So that's how you start a program from this address. This address. Show you one more time. And for this demo, I'm going to start a program from local computer instead of this web address, because I want to show you some quick response of these programs. If I start from local, it'll be slightly faster, easy for me to manipulate. So I'll just show you one more time this address, asp.civilbay.com/connect. So for normal user, you can start it from the web address. And for me, in this tutorial, I'm going to start a program from my local computer. So just want to be quicker. So copy and paste and hit enter. You will start a program from the web browser. Alright, so now I close this one and I will start the program locally. So the address will be slightly different, but it's faster. Before I proceed, I will just want to show you a web tutorial. Before I proceed for very quick demonstrations, I will just assume you already know our interface. You already know our interface, how to use these programs. If you don't, and you can go to YouTube, our YouTube tutorial. You type CivilBay, go to YouTube, type CivilBay and do a search. You will find our channel here. CivilBay AISC steel connection design. You can go to tutorial. This latest
it's free.
one.
So download it and set it as your.
So this. First, go to YouTube, type CivilBay. You will find our channel, CivilBay AISC steel connection. On this video, it's called 01 steel connection, AISC steel connection design, quick start, June 2020. please watch this video. Basically tutorial, please watch this video tutorial before you see current video, because this tutorial show you the basic interface introductions, how to print, how to save file, and how to do the input. Everything it's a brief introductions on how to use this program. All right, so in our current tutorial, I'm not going to repeat the introduction one more times. I will run very quick. Okay, I would suggest you to watch this tutorial in our channel before watch current tutorial, because current one is very quick introduction, very quick going through the detailed connection design. Will not cover the basic introduction of how to use this program. All right, so close this one, and okay, let me see. Quick start video. I'll just show you how to start a program link. I'll just show you. Okay, and also this PDF file. Okay, in our this PDF file will go through throughout the tutorial. Okay, and connection, and you can download this PDF file on a link below. All right, to work with these videos. So you can download it and open the PDF file and go through the tutorial step by step with us. Okay, this PDF file, the download link is on the description below. Okay, PDF file. So this tutorial mainly cover the brace connection and shear connections, and these are two main types. There's no moment connection on this tutorial. All right, so this steel connection is based on AISC manual book, and also AISC design guide 29 here. Okay, I believe most of you have this design guide 29. All right, so I close this one. Design guide 29. I close this one. Okay, let's start now. Okay, I will close it. Okay, let's start now. So before start everything, I'm going to set the code. Okay, go to setting. I will use AISC how to say AISC 15 edition LRFD code. Okay, the unit will be imperial. Okay, and the display precision will be inch 0.001. Okay, so that's a code. AISC 15 editions LRFD, unit will be imperial, and precision will be 3 decimal. All right, so I will okay here. So that's a design code and display unit, and the design unit. Okay, I will show you. This one. So okay, here you go. So this inch, and the force it display is kilonewton. Okay, everything is imperial, and code is American code. But for some reasons, design engineer, they use kilonewton as force. I'm going to convert it to kips. All right, so that's what I want to tell you for now. All right, so let's get started. Okay, now let's get started. Okay, so basically the connection I will show you is that's a 3D isometric. It's a pie rack. All right, a steel pie rack, and it's a truss, 3D truss, cover these 3 grid line, and that's isometric, 3D isometric, view, and there are horizontal brace and vertical brace. Okay, so what I'm going to start is elevation here. All right, that's the elevation 301, and I'm going to start the connection 458. So that's a vertical steel connections and vertical brace. All right, so I'm going to show you the connection. All right, so 458. All right, so all right, so 458. No. Okay, this guy. Okay, 458. So that's grade 306. Okay, vertical brace and strong AISC. Okay, so 306 is this guy. All right, so you see here the I don't know this connection 458 vertical brace. I move this out, move this in again. Okay, so now that's vertical brace. I'm going to start this one 458. All right, so these are pass-through force or transfer force. So I'm going to start this one. I move this out and show you our interface. Okay, so just have a brief to you on these connections, and I will move this out to another screen. So basically, I go to general after the setting. Okay, I choose a brace connection and it's a strong AISC. Okay, so basically the next step, all right, the column is 250 by 58 and the beam is 200 by 46. So again, these are just metric designation of AISC sections. Okay, and we can also call it Canadian sections. So for American users, 250 is 10 inch. Okay, W10, and W246 is W8. All right, so this angle L12789 is just how to say angle 5 inch by 3.5 called or 3.5 inch. All right, so the force unit, I'm 30 kilonewton. I'm going to convert this one to kips. So for American user, and these sections are Canadian section or AISC section in metric designation. So just let you know, I'm going to pick up this section from Canadian Steel manual book. All right, so I'm going to start. Okay, and again, these diagonal brace, I'm going to the angle between diagonal brace and horizontal is 42.5 degree, and then the angle between brace and vertical line is 57.5 degree. Okay, this program only take angle to the vertical line, so I'm going to show you that later on. All right, so I just mentioned the angle. Okay, angle brace incline angle from vertical line is 57. What's that? It's 47. Sorry, 47.5. All right, 47.5. I'm going to input here 47.5. all right, so you see here 47.5 is corresponding to this angle. Okay, So this angle is 42.5, so that's 47.5 to the vertical line. Okay, we only use the angle to the vertical line, so 90 degree minus this one is 47.5 to the vertical line. So the this brace is double angle vertical is 12789 and half inch. All right, 12789 half inch. It's a double angle vertical. It's 2L, right? So I'm going to choose double angle vertical. Okay, and the section it's 127. I go to here. I choose Canadian book 12789 long net vertical 12789 half inch 12789 half inch. Okay, 12789 half inch. Create OK, and there are 3 bolts here, 3/4 bolts, 3 rows of bolts. All right, so and I go to 3. All right, so and copy suggest. Okay, I don't know. Copy suggest the gauge here is display 125. Get the bigger view here. The gauge is 3 inch. Okay, gauge 3 inch here. So let me check. 3 inch, 2.5. I have to change it. Okay, 3 inch. Update. So I gauge change to 3 inch. Why is 3 inch? Why this gauge is 3 inch? That guy Nami batch followed it. Okay, so and now the column. Okay, the column is 250 58. The beam is 246. Okay, column and go to section and 250 58. Canadian section 250 58 250 58, and the beam is 246. Canadian section 246. Okay, 246. Okay, now we get everything done right. See here, I probably okay, I probably can show you in one screen. Okay, so basically we get everything set, and there's 3 rows of bolt. Okay, and what to say that it's 3.5, 2.5. Okay, 3.5, 3.5. Okay, let me see. Gusset to current 2.5. It's 2.5. Okay, 2.5. All right, and this one is 3.5. 3.5, and this one is 1 3/4. What they say, 1 3/4. 1 3/4. No, not this one. That one. 1 3/4. 2.5. 3.5. Gauge. Gauge. Let me see. Section. What's the gauge? 3.5. Okay. Gauge. And it's 16 plate. 16 is 15.8. Okay, it's 5/8 plate. I believe it's 5/8 plate. Okay, so gauge 3.5, it's 15.8 millimeter. It's 5/8 plate. Okay, all right. So gauge 3.5, 3.5. The plate thickness is 5/8. It is 0.625. All right. So now you see here 2.5. See the highlight, and edge distance 1 3/4, 3.5. All right. Gauge and 3.5, and plate thickness 5/8. 5/8. Okay, see the highlight. So we get this done. See all bolts 3/4. All right, that's 3/4 default in our. So we get 2.5, 3.5, 3.5. Gauge 3.5 and 5/8 plate. And now this gusset plate thickness is what is gusset plate thickness? Where's gusset plate thickness? But it didn't show. No, it didn't show. Plate steel, being steel. Let's say 3/4. I couldn't wait. Now it's 3/8. Okay. So anyway, now here you see it's 5/6, 5/16, and 1/4. All right. So go to web. Okay, gusset to bin. 5/16 is here. Copy. I believe that one is 1 feet, and it go vertical, and this one is 1 3/4. Okay, so and the force here. Okay, now see here, 2 bolts here. Okay, 3.5 spacing. Okay, 2 bolts here. So I will go to bin to column. I have 3 bolts here. I will go to bin to column. I want to go to 2 bolts. 3. Okay, 2 bolts. Okay, and what's the weld? Weld is the weld is 1/4. 1/4. All right. Weld here. Weld here. Okay. 1/4, and go to gusset column. Weld here, 1/4. Update. All right, pretty much we are set, and the design force 340 kilonewton. Compression tension. Okay, we go to 340 kilonewton. 340 kilonewton. It's 76.5 kips. Okay, 76.5 kips. Go to design mode. Okay, first tensile 0.5. Okay, and 76.5 compression is tensile is negative compression. Okay, another force is pass-through force. All right, pass-through 30 kilonewton. I believe we input tensile. Okay, so tensile pass-through force. See the notes. Tensile plus signs for tensile transfer force. So we input the as tensile to be conservative. 30 kilonewton. No. 30 kilonewton is okay 6.75. all right, pass-through force 6.75, 6.75, and the shear force, all right, shear force with 1500. It's not necessary, it's so big. All right, there's no tensile, it's huge shear. Okay, it's just meant they just input 50% of capacity that's not needed. So anyway, 1500 kilonewton, 1500, it's 337.5, 337.5. okay, there's no x6, 0, 0, and 337.5. Strong x6. Update. All right. It fails. What's this? Is ridiculous. What's this one? Why such huge shear? The beam section 50% shear capacity, just it's something wrong. Okay, the 50% of this section is just 34 kips. So that guy showed me 1500 kilonewton. That's wrong. It's 150. All right. So 150. It's 150. So it's 34. Okay. Something wrong. Okay. That's a typo. Okay. 34 kips. All right. So 50%. It's 34. You see here. 34 kips. That guy is typo. It's so obvious. Okay, 34. Update. Okay. Now we finished input of force. We have tensile. See here, tensile. That is 76. We have shear force 34. We have pass-through force. The ratio is 1.33. Okay, so pretty much we finished this one, and we're going to check what's wrong with this 1.33. Summary: it's beam to column, so obvious. Okay, we check to beam to column. 1.33. Anything wrong here? What's wrong here? It's beam weld strength. Okay. It's 1/4. It's too much. 1/4 inch. All right. It's nothing to do with weld size. It's a rupture. Okay, beam column. Beam to column. It's a weld line. Beam to column. Front view. Just these two weld line, and the shear resistance, that means it's not the weld failure, it's the base material failure. All right, so we are going to increase the weld line, length of weld line, increase the web size, base material, increase the web size will not work. Okay, so beam to column, what I can do is I do this, I do this, I increase weld line, okay, it get passed. So apparently, okay, it also weld the top and bottom, the flange part, okay. So so that's right. So no wonder we need this one. We also weld the previous one. It's not matching it's not matching this guy because you weld here, you weld the flange. All right. Both flange and web. So we do this. We do this. All right. Go to bin to column. Bin to column. We do this. It pass. Okay. So we finished this design. We finished this design ratio 0.83. This guy, okay, we finished this guy, all right, and these connections with brace connection. Okay, basically we finished this guy. Okay, 458. So now, okay, go to we show some sketch. We don't show this one. We show sketch. Okay, show sketch. Print. So it's a nice sketch. You see here the design. Okay, before seeing that, this connection, all right, this connection 340 kilonewton, double angle. It's here, all right. That's way more sections for gusset plate. Okay, that's from view. All right, so finish this one. So now we're going to 306 VX6. Okay. We finished this one. It's a strong X6. So now, you see here, that's a strong X6. Okay, go to VX6. These elevation 306, 306. At this elevation, there's also vertical brace to the VX6. Okay, so go to elevation 306, 448, 458, 306 here. Okay. 458. So we have another connection in the VX6. We have also vertical connection, and this one, two side. Okay, this side is 102 76 by 8. This side is double angle 76 76 6. Okay, so that's 458. Okay, that's this guy. So I'm going to do this. All right, so we are going to do this, and let me do this. Show you guys this one. The angle is 35. I don't know, 35.8. It's 44 to the vertical. All right, to the vertical line. So I'm going to do this first and do that one for second. So basically, for this connection, I'm going to split into two, and we do the right side, assuming there's no left side. We do the left side, assuming there's no right side. And the relation between these two is this pass-through force. Okay, it's pass-through force. We do it separately. Okay, so let's do it. Okay, so I will show you how to do that. I don't know, because I tried to get this guy minimized somewhere. I tried to get this guy minimized somewhere. Alright, we do this one first. You see here. So see the angle 35.8. We change to 35.8. 35.8. So we get 35.8 general. Okay, 35.8 is somewhere here. Go to low view. Let's know. show section, right? Section 35, 36 here, all right? So basically 35.8, and that's 3 of them, 102, it's 127.89 now, it's 102, change it, okay? So change to 102.36.8, okay? 102.36. $36.8. All right. So that guy is to VXX, is general. Gusset connect to colon web. VXX. Okay, that guy is to VXX. So that one I copy all, and let's see the gauge. It's 2.5. It's my 2.5. Okay. No. Gauge 2.5 here. 2.5. Okay, assume everything I accept it. Okay, so now it's I accept this one. 3 that's correct, and go vertical 1/4. It's 1/4. Okay, I want this the clearance to it's not clearance to the flange, it's clearance to the web. I can do that. So for me, now my clearance is 1 inch to this one. If I want to clear to this one, what is this? Clear to this end plate, I just type -2 here. Positive value clears to flange. Negative value clear to negative value clear to these, but it clear to here. Okay, let me see. Minus H, but anyway, it goes inside. Ends up this one govern. So maybe okay. So now gusset to beam. I copy, go vertical, and it appears is 1/4, 1/4, and 250 by 58. The beam size is 236, so I have to change it. Okay, 236 section. I have to change to 236. Okay, I believe it's 1/4. Oh, everything is 1/4, 1/4, 1/4, 1/4 the weld size. Being the column 1/4. Update. Gusset to column 1/4. Gusset to beam 1/4. Okay, 1/4. And copy. 1/4. Okay, go vertical. All right. So now, what's this? There's a stiffener plate here, but I don't know if I have the options. I probably have. And the end plate is gauge is 3.5 inch and 1/2 inch thickness. Okay, so end plate. No, it's 3/8. It's no 1/2 inch, 0.5, 0.5, 1/2 inch, and the 1/2 inch and 3.5 inch gauge. All right, so get everything set. Gusset plate thickness. It's 1/2 inch. Okay, gusset plate 1/2 inch. Gusset plate thickness is ½ inch. Alright, so now the force. 190 kilonewton. 190 kilonewton. 190, it's 42.8 kips. 42.8 minus 42.8 plus 42.8, and no transfer force. Shear force is half, 128 kilonewton. Shear force is half of it, 128 kilonewton is 28.8. okay, 28.8, okay, 28.8, 28.8 is the same here. It's half of this, okay, 42.8. Update, okay, the force 0.75. So that's the vertical brace to the column weak axis, okay, and that guy, that guy we finished this one. So now I'm going to do this, okay. So this side, it's a knee brace, all right. It's a knee brace. As I say, we do this side assuming there's no left side, okay. We do left side assuming there's no right side, and the relationship between these two is a transfer or pass-through force, okay. You can input. We take this connection as 2. We take this connection as 2 connections separately. The relationship between these two is transfer force. So now I'm going to do this one, okay, this one, the left side. So again, I'm going to do this. So general, it will be knee brace, okay, and column at the right, all right, and connect to web, and the angle 44 to vertical 44.3. Okay, gusset to column, and then copy. Alright, apparently they want what's the distance of this? I don't know. I had to measure. Let's say 6 inch from distance from 6 inch. Gusset to column 6 inch. Update. No good. (9" update. Let's copy it. Alright, let's go to horizontal. I don't know. Let's go to horizontal. Okay, that one, that distance appears be 2 inch. Something's 2 inch, 3 inch. Let's go for 2 inch. 2 inch update. Okay, that looks much nicer, and the clearance is to this one, to the flange now. So we do 1 inch gusset plate, 1 inch clearance now is to the web. Let's do 1 inch to flange. Okay, so why it's so weird? Gusset to column no, gusset plate. That number is wrong. Okay, so 1 inch. All right, so 1 inch to this guy. We go to flat, okay, and 44 generally. 44.3, okay. Go to 2 inch. Gusset plate half inch. 3, 76, 76, and 6. 76, there's equal angle. 76, 6. Alright, so 76 and gauge. What's a gauge? 1 3/4. Okay, 1 3/4 here, and copy everything. 1 3/4, and 3 of them. Okay, it's 120 kilonewton. That one is too wide. That one is too wide. We just go to straight here. Okay, I don't have this, but I just go to here. Alright, so 120 kilonewton. What's the force? 120 kilonewton is 27 kips. Alright, so 100. What's the force? Design note. Okay, unit conversion 27 kips. Tensile minus 27, positive 27 is compression. Update. Alright, 0.35. So that one will go to straight gusset to column. Copy this one. Copy. Alright, so the wet line is 1/4 3 side. It's 1/4 3 side, and 120. I think I'm done. Okay. So look at this. Look at this. Look at this. It's a knee brace. All right. So I'm finishing this one. It's a knee brace. Okay. Knee brace. Wait more section. Okay. Finish the second one. So I don't know how long it takes. Finish this one. Now I'm going to take the base. I'm going to take 458. It's done. And go to 434. It's a brace. Okay. Alright, I'm going to do this. We finished this one. Alright, 458 and 306. We also finished this one. Alright, the VX6 side, strong X6 side. No, this one, strong X6. Now we're going to do this. This one, 34. There's also strong X6. Okay, strong X6. That's a base plate. Vertical base plate, and also there's VX6 306. Where's 306? Okay, 34. It's also VX6. So now is it 34? 34. Yes. All right. So go to 34. We have strong X6. Okay, we have weak X6. So let's do strong X6 first. Okay, Alright, so it's this one. Oh, it only show one side. Okay, it's only this one. It's vertical brace, base plate, strong X6. Okay. So now general. I'm going to move this one here. Okay, but I'll move this guy out for now. Try to move him. Okay, so base plate, vertical brace, base plate. Anyway, I put on the other screen. Okay, I don't know. It's difficult to do the screenshot together. Okay, so you won't see the sketch. Anyway, I do it for you. The brace is 1 to 789. The angle is 346, 46.3, 46.3, 46.3. The column is at the left side, to strong X6, to flange, and the angle is 1 to 9, 1 to 989, long leg vertical, 1 to 789, half inch, copy. I don't know why they use 3-inch gauge. Update 1-inch gap. Okay, the base plate is anyway. I don't know. The base plate is 5 and 1/16. 5 and 1/16. And the both side is 10 and 1/8, and plus two sides 10 and 1/8, plus the depth of 250, depth of 250, column section is 9.921. It's 10-inch. Okay, it's 10.02. okay, so base plate. This one is 10. Okay, so then the weld is 5/6, 1/4, 5/6 and 1/4, 5/6, 1/4. Okay, that's great. And we flush the gusset plate. Alright, so the force is 340. Force is 340. Alright. Okay, the brace force, tensile compression, it's 340 kilonewton. Okay, so 340 kilonewton. And one more time. 340 force, 340 kilonewton is 76.5. all right, so it's where is it? Okay, so basically it's I off the two tip. Okay, two tip, get it off. So these are preset value. I clear off then to 0 before input. No, clear off then to 0. Okay, so what's this? Oh, I have two. Okay, I close this guy. Okay, let's use this one. I turn off the two tips. I clear all preset value to 0. Alright, so let me verify this one. 250. Okay, let me verify this one. 250. Get this one here. Get this one here. Okay, 250 by general. Okay, 250 by 58. Oh, that one is 12789 12, and the angle is 46 degree. Angle is 46 degree, correct? Okay, angle 46 degree. It's 345. 334. Okay, so angle is 46. This one is it's 10. Okay, and I can move this guy here. I try to accommodate in one single screen. Okay, all right, so 1/4, 5/16, 1/4, 46 degree, 10 inch. Okay, that one deduct the creep, it's around 4 inch. All right, so 12789, 340. What's the plate thickness? Plate thickness is 1 inch. Okay, 1 inch. And the 340, it's 76.5. Okay, 76.5 compression, 76.5, and this one tensor minus 76.5. all right, so all these force, okay, these are brace actual force. Okay, the rest we pretty much design the base plate and anchor bolt. All right, so we have that's a base plate. We design all the weld. You know, there is a vertical brace and the column, and the maximum when we get the force for base plate, the maximum foundation load is a combine of actual force from brace and actual force from column. And these maximum actual force might not happen in the same load case. So it ends up when we design a base plate, we only care about maximum foundation compression or tensor, which is the combination of brace actual load and the column actual load, and the might not be the load case where maximum brace actual load and maximum column actual load happen. So we have lots of input here for different design purpose, okay, and like this one, base plate maximum compression force is for base plate only, and that base plate maximum compression doesn't mean that load case, in that load case the brace load get maximized, okay, and maximum value. There's no guarantee because there's this guy here which have to combine this actual load. So we have two input here for different design purpose. So for this case, if you are not designing, if you're a connection engineer, okay, the base plate thickness is given by steel design engineer. You need not to care about the base plate design. You can just for this example, right, you have a base plate, you have base plate size, thickness, thickness given by steel structure engineer. You are a connection engineer. They already specify the base plate size. You don't need to design a base plate. So you can ignore these base plate, the force for base plate. You only care about the brace actual load, which is 76.5 kips. Okay, what I say is 340 kilonewton, 76.5, which is okay here. So now we key in 76.5. We key in that's no compression is positive value, tensor is minus value, 76.5. Updated. All right. So you have 76.5 compression. Okay, you have 76.5 tensor. That's all you need to care about. So well, we pretty much finished the connection of this guy. We finished the connection of why is that? We finished the connection of this guy. All right. So it's 1 inch thick base plate. Okay, 1 inch thick, and that's 340 kilonewton. We finished a strong AISC. Okay. Of course, if you have stiffener plate, we can do that here somewhere. If the column check crippling or whatever will not pass, gusset column. Direct weld. Okay. General, there's somewhere for column provide stiffener plate, a column web. Okay, so we can provide a stiffener, but for this case the column pass, so we don't need that. No. Okay, so we finished this one, and we finished this one. Okay, maximize it. Okay, 75, 100. Okay, we finished this one, which is I believe which is 75. Okay, come here, which is this guy 34, right? 100, which is this for this base plate, and go to elevation 306. We go to 306. There's weak AISC. Okay, 35. Okay, so 34, which is weak AISC. Okay, weak AISC, and we do this design for now. It's this guy. All right, so now we're going to design this. Okay, and I will pull up this one, come here, we will show you here, design this. Okay, alright, so now the angle changed to 35.2. okay, general 35.2, 35.2, and the column is on the right side, and it's go to column web v-axis. Okay, gusset to column, I copy this one. Alright, so 35.2 general, okay, so 102.76, this one is 102.76 and 8. Okay, so change it, 102.76, 102.76 and 8. Okay, so copy, and the gauge is 2.5. Gauge, what gauge this guy use? It didn't show. Okay, then we keep 2.5, 3 of them. Clear 1 inch to the flange, yes, and need the base plate here. Okay, so gusset to column, we copy it, and we need column web, we need to stiffen the plate, and the weld, so 1/4, 5/16, 1/4, and it's a 9 inch. Okay, it's 9 inch, that's great. 1 inch thick plate. Alright, so the force is, it appears everything is set. The force is 190 kilonewton, so 190 kilonewton, 190 kilonewton, it's 42.8. okay, 42.8, design load, where is it? 42.8, 42.8, and minus 42.8, minus stand for tensor. Okay, so we finish this design. All right, so v-axis connection. Okay, v-axis, and here's the connection design, vertical brace, base plate, and the so see here, get okay, we get this whole, it's nice, very nicely presented, v-axis base plate, vertical brace connection design. All right, okay, tell you tips. Normally I believe most 100% engineer now have work on the dual screen. Okay, and so when you want to compare a sketch to the input here, okay, whatever, you have dual screen, one screen show this one, and what I do is I go to unfold this one, say I want to see this part. Okay, I want to see this part too. Okay, so I click on print, and I pull up a window, okay, which is the content I want to review against the previous one. So I can put this one into the second screen, okay, and compare and check. All right, so I move this in, move this out, moves in, then moves out to the second screen and compare to whatever shown. So I actually have 3 monitors now, so I can just use the print, okay, to pull up a new window to display the content I want. Okay, and move to the third screen, so I can compare these contents. Okay, I have another one here. Okay, I have one more here. Okay, and if 3 monitors, I can compare to this guy to whatever content here, and that's how it works. Okay, that's a tips. So now today I'm going to finish part 1. all right. Basically in this video we only talk about the rear steel connection project. Okay, we only talk about 4 connections, brace connections. We demo 4. They are going to be part 2, 3, and 4. I believe each part I probably can only talk about 4 and 5 connections. So continue with the next part 2. Okay, and see you next time. Bye bye.